Good afternoon. Just here doing some pre-start checklists. Sure, you know how it is. Everyone wants to hopefully see the launch, so alrighty. Suit or secondary coolant loop valve is good. Steam pressure. Mark. Increase for 58 seconds. We're just gonna let the computer hold that switch for us so I don't give my finger a cramp. Making sure I don't let go of that. The pre-launch procedures are a little lengthy. We are currently sitting at T-minus 3 hours, 32 minutes and counting. Of course, we will likely be time skipping more, but maybe not for another 15 minutes or so. Just let some more people join. There we go. And decrease for 8 seconds. 1, 2, 3, 4, 5, 6, 7, 8 mark. Okay. Com activation, sure. Should show gray after 90 seconds. We'll time skip through that. Here we go. Should be gray now. There it is. VHF AM duplex. All right. So here we do a test of the comm system. And the voice check comes in nicely. Intercom. S-band VHF goes to 7. Here we go. Caution and warning, power off. And we'll open the circuit breakers now. And this completes the backup crew portion, and we'll wait for prime crew ingress procedures. Here we go. Preparing for prime crew ingress now. Comm deactivation. Caution warning, circuit breakers close. Potable water tank inlet open. Food preparation station. The circuit, or not the circuit breakers, the stuff here has to be open. So open, open. Just has to be open until, open for the first time. It pops a seal on that pipe. Now we need to adjust for 0.6 to 0.8. Which I think should be about right there. Suit compressor. Verify program 2. Yes, this is one of my favorite spacecraft. I think Gemini might be my favorite. It's sort of underrated. And then it's Apollo, and then it's Space Shuttle. Time for ingress. Here we go. CDR, ingress, left-hand couch. Suit power on, up, power audio tone. Cabin fans, 2 on. Float bags vent. Abort handle neutral. SCS standard switch configuration set. Delta V center of gravity set. Lunar module pilot ingress right hand seat. Suit power on up, power audio tone. SPS gauging AC1. Glycol pumps 1, AC1. Good. VHF antenna select SM left. Oxidizer flow valve increase normal. Main A, main B reset sensing circuitry is normal. S-band standard comms configuration, Omni Bravo. All is normal here. Command module pilot, ingress center seat, suit power on, up, power audio tone. Caution warning, boost, event timer, mission timer counting. Suit water accumulator, auto, 1. Suit compressor Delta P is go. Uplink telemetry command normal. Uplink telemetry command module block. CMP PADCOM off. Emergency detection system testing. EDS power on up. EDS auto on. Verify abort light operation. Standing by for abort light. Abort light operation verified. Uplink telemetry command off. Comms off. Okay. Command module pilot will be going through a test out of the emergency detection system now with the pad comms. So we've taken them off of the rest of the comm loops. Interestingly enough, I'm not getting any of the audio that is supposed to be playing at this point. But we'll continue along and see if it comes up eventually.
This is Apollo Saturn Launch Control. It's the crew aboard the spacecraft, the 320-foot level. The hatch is closed, and we're beginning to purge the cabin to bring it to the proper atmosphere for launch, which is a combination of oxygen and nitrogen, 60% oxygen and 40% nitrogen atmosphere. Of course, the astronauts themselves are breathing pure oxygen through their spacesuits. This is Apollo Saturn Launch Control, T-minus 1 hour, 30 minutes, 55 seconds, and counting. All elements are go with the countdown at this time. The countdown aimed toward landing 2 astronauts on the moon. At this time, the spacecraft test conductor, Skip Chauvin, going through some checks with astronaut Mike Collins aboard the spacecraft. We're winding up this important emergency detection system test that Neil Armstrong has been participating in. Meanwhile, at the 320-foot level, the closeout crew now placing the boost protective cover over the hatch now that we have completed the cabin purge and have the proper environment inside the cabin. We have also performed leak checks to assure ourselves that the cabin atmosphere is valid. This boost protective cover is used during the early phases of the powered flight and is jettisoned with the escape tower shortly after second stage ignition. Here in the firing room, the launch vehicle test team still keeping a close eye on the status of the propellants aboard the Saturn V launch vehicle. We're back to 100% supply with the liquid hydrogen fuel in the third stage. This problem with the leaking valve is no problem at this time. We've actually bypassed the valve, but we are maintaining our hydrogen supply aboard the vehicle. All aspects go. The weather is very satisfactory for launch this morning. A thin cloud cover about 15,000 feet. Temperature at launch time expected to be about 85 degrees. T-minus 1 hour, 29 minutes, 30 seconds, and counting. This is Kennedy Launch Control.
All right, you heard the announcer. EDS test is currently in progress. EDS test is now complete. All right. There's the O2 system. All right, we finally got her. IU is block. All right. Gyro power up. Caution and warning, normal. BMEG temp lights are out. FTI GPI power off. SCS power GDC ECA BMEG 1 and 2 on. FTI GPI power both. BMEG temperature lights off. Caution and warning mode acknowledge. GDC align. FTI select ball 1. Source at set. 162.90. GDC align push button push. No motion. Release. GDC set 168. 81. Yaw 355. FDI select ball 2. GDC align push. Null motion. Release. Roll set 162. 90, 0. FDI select, ball 1. GDC line push button push. Null motion, release. Sequential event control system, disarm. Fuel cell initialization. Fuel cell 1, tie, main bus A. Fuel cell 1 online. Fuel cell 2, tie, main bus B. Fuel cell 2, rev up. Fuel cell 3, tie, main bus B. Fuel cell 3, online. Main bus ties, on. Thrust vector control servos, on. Gimbal position check, pitch 1, start. Yaw 1, start. Trim check. Minus, plus, 0, minus, plus, 0. Manual thrust vector control verifies go. Full range of motion. SCS pitch and yaw to auto. Pitch 2 start. Yaw 2 start. Abort handle clockwise. Trim check. Minus, plus, 0, minus, plus, 0. Verified. Manual thrust vector control, full range of motion. Auto switch over check, pitch 2 off, yaw 2 off. Verify no manual thrust vector control. Abort handle neutral. Set launch pitch trim minus 1.5. Yaw launch trim plus 1.3. Pitch 1 off, yaw 1 off. Batteries off then auto. Thrust vector control servos off. Launch vehicle indicator select tanking pressure. FTI select ball 1, 2. Source CMC. EMS roll on. GDC line push button hold. Yaw through 45 degrees. Yaw 0. GDC line push button release. EMS roll off. GDC IMU differential negligible. No alignment needed. EMS Delta V set for launch.
This is Apollo Launch Control at 1 hour, 7 minutes, 25 seconds and counting. Countdown still proceeding satisfactorily. For those people who would like to synchronize their watches in relation to the count, we'll synchronize on 26 minutes past the hour, which is now about 65 seconds away. We'll count down the last 5 seconds to 26 minutes past the hour. We're now 1 minute away from 26 minutes past the hour. In the meantime, we do have information from the civil defense agencies in the area. The estimate is more than 1 million persons are in the immediate area in Brevard County to watch the launch.
That's a lot of people in it.
This is Apollo Saturn Launch Control. We've just passed the 56-minute mark in our countdown. We're still proceeding in an excellent manner at this time. All elements reporting in that all systems continuing to look good at this point. We're still aiming toward our planned liftoff at the start of the lunar window, 9:32 a.m. Eastern Daylight.
Okay, caution and warning modes boost. Uplink telemetry command normal. Begin preparations for pad abort enable. Oh, we closed the hatch a long time ago. Yeah, that hatch has been closed for like 3 hours now at this point. Okay, pad abort enable. EDS power on. Gearbox select latch. Command module RCS logic on. Pyros. And we'll go for pyro arm. Pyros are armed. Pad abort enabled.
This is Apollo Saturn Launch Control. We passed the 41-minute mark in our count. T-minus 40 minutes, 53 seconds, and counting. We are continuing, and we're continuing very excellently at this time. There are no problems that have been reported in as the countdown continues to click down. We're still aiming for the start of our window on this, the first flight to land men on the moon. We're aiming toward our planned liftoff time of 9:32 a.m. Eastern Daylight Time. Coming up shortly will be a key test here in the firing room as far as the launch vehicle people are concerned. It's some final checks of the destruct system aboard the 3 stages of the Saturn V launch vehicle. In the event during powered flight that the vehicle strayed rather violently off course, the range safety officer could take action to destroy the vehicle. This obviously would occur after the astronauts were separated by their escape tower from the faulty vehicle. We make a check of the destruct system to assure that if a signal is required to get through, that in fact it will. This is what is coming up here in the control center at this time. All aspects of the mission still go. We're at T-minus 39 minutes, 47 seconds, and counting. This is Kennedy Launch Control.
Yep. The emergency destruct system. That is a real thing on this vehicle. And Gunther is not in the control center. He is sort of, I believe, about right here. Far enough away from the launch that it's not a... it might actually, I think it's right here at this Apollo service structure. Let's see. Yeah, the manned service structure. Crew transport. Yeah, it's right here. Yep. That's where he is right now, just in case he needs to come back to the pad with the red team. Red team are the people that come out and fix the vehicle if required, which of course was required on Apollo 11. They did have that leaking valve located about right here at the 200-foot level. And yeah, they eventually fixed it about an hour ago, if I remember correctly.
This is Apollo Saturn Launch Control. We've just passed the 31-minute mark in our count. With T-minus 30 minutes, 52 seconds, and counting, aiming toward our planned liftoff time of 32 minutes past the hour, the start of our launch window on this mission to land men on the moon. The countdown still proceeding very satisfactorily at this time. We just got by an important test with the launch vehicle. checking out the various batteries in the 3 stages and instrument unit of the Saturn V. We remain on external power through most of the count to preserve those batteries which must be used during the powered flight. We've just taken a look at them by going internal and then switching back to external again. The batteries all look good. The next time we go internal will be at the 50-second mark with those batteries, and they will remain, of course, on internal power during the flight. The lunar module, which has been rather inactive during these latter phases of the count, also is going on internal power at this time on the 2 batteries in the ascent stage and the 4 batteries at the descent stage. For the next 20 minutes, we'll take a look at some systems in the lunar module, then power down at about the 10-minute mark in the count, power down the telemetry to preserve the power of the lens. The lunar module in Apollo 11, of course, when it separates from the command module in lunar orbit, we'll have the call sign Eagle. The command module call sign, once the 2 vehicles separate, will be Columbia. Both Columbia and Eagle go at this time at 29 minutes, 24 seconds, and counting. This is Kennedy Launch Control.
Okay, 28 minutes. That means we are go to terminate cryostir. And at the 25-minute mark, here we are, 25 minutes. We are go for primary SMRCS activation. Good. 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 All right. SMRCS is active at this time.
This is Apollo Saturn Launch Control. We're now less than 16 minutes away from the planned liftoff of the Apollo 11 space vehicle. All still going well with the countdown at this time. The astronauts aboard the spacecraft have had a little chance to rest over the last few minutes or so. At least they haven't been busy with procedures with the spacecraft test conductor. In the meantime, we have been performing final checks on the tracking beacons in the instrument unit, which is used as the guidance system during the powered phase of flight. Once we get down to the 3-minute and 10-second mark in the countdown, we'll go on an automatic sequence. As far as the launch vehicle is concerned, all aspects from there on down will be automatic, run by the ground master computer here in the firing room. This will lead up to the 8.9-minute mark in the countdown when the ignition sequence will begin in those 5 engines of the first stage, the S1C stage of the Saturn V. At the 2-second mark, we'll get information and a signal that all engines are running, and at the 0 mark in the countdown, once we get the commit signal, the signal that says that the thrust is proper and acceptable, we then will get a commit and lift off as the hold-down arms release the vehicle. We have some 7.6 million pounds of thrust pushing the vehicle upward, a vehicle that weighs close to 6.5 million pounds. We're now 14 minutes, 30 seconds and counting. This is Kennedy Launch Control.
Okay, emergency detection systems now been taken into auto command of all abort if we need. RCS command is off. Standing by to latch the fuel cells.
This is Apollo Saturn launch control. We passed the 11-minute mark. Now T-minus 10 minutes, 54 seconds on our countdown for Apollo 11. All still go at this time. The astronauts in the spacecraft busy again. The commander, Neil Armstrong, has performed some final switch settings for the stabilization and control system of the spacecraft. The spacecraft also now is on full internal power. This came shortly after the 15-minute mark. The spacecraft now on the full power of its fuel cells. Up to this time, it had been sharing the load with an external power source. Both Armstrong and Buzz Aldrin have armed their rotational hand controllers, the controllers they use in flight. And we have now gone to automatic system with the emergency detection system, that system that would cue the astronauts if there's trouble down below with the Saturn V rocket during the powered flight. We're now coming up on the 10-minute mark, 10 minutes away from our planned liftoff. Mark, T-minus 10 minutes and counting, T-minus 10. We're aiming for our planned liftoff at 32 minutes past the hour. This is Kennedy Launch Control.
Okay, 6 minutes.
This is Apollo Saturn Launch Control. We passed the 6-minute mark in our countdown for Apollo 11. Now 5 minutes, 52 seconds and counting. We're on time at the present time for our planned liftoff of 32 minutes past the hour. Spacecraft test conductor Skip Chauvin now has completed the status check of his personnel in the control room. All report they are go for the mission, and this has been reported to the test supervisor, Bill Schick. Launch Operations Manager Paul Donnelly reports go for launch. Launch Director Rocco Petrone now gives a go for 5 minutes, 20 seconds and counting. Coming up shortly, that swing arm up at the spacecraft level will come back to its fully retracted position. This should occur at the 5-minute mark in the count.
Swing arm coming back.
T-minus 4 minutes, 50 seconds and counting. Skip Chauvin informing the astronauts that the swing arm now coming back. The astronauts will have a few more reports coming up in the countdown. The last business report will be from Neil Armstrong at the 45-second mark in the count, when he gives a status on the final alignment of the stabilization and control system. We're now passing the 4-minute, 30-second mark in the countdown. Still go at this time.
T-minus 4 minutes, 15 seconds.
4 minutes, 15 seconds. The test supervisor now has informed launch vehicle test conductor Norm Carlson you are go for launch.
T-minus 4 minutes. PADCOM off. Launch vehicle lights verify on.
3 minutes, 45 seconds and counting. And the final abort checks between several key members of the crew here in the control center and the astronauts. Launch Operations Manager Paul Donnelly wished the crew on the launch team's behalf good luck and Godspeed. 3 minutes, 25 seconds and counting. We're still go at this time. 3 minutes will be coming up in the automatic sequence about 10 or 15 seconds from this time. All still go at this time.
Okay, all flight controllers coming up on auto sequence.
Good wishes. Thank you very much. We know it will be a good flight. Firing command coming in now. We are on the
Auto sequence.
We're approaching the 3-minute mark in the count. T-minus 3 minutes.
Program 2.
T-minus 3.
Verb 75, do not enter.
Elements of the mission at this time.
Tape recorder in motion.
We're on an automatic sequence as the master computer supervises hundreds of events occurring over these last few minutes. Two minutes, 30 seconds and counting. We're still go on Apollo 11 at this time. The vehicle starting to pressurize as far as the propellant tanks are concerned, and all is still go as we monitor our status board.
Coolant loop bypass.
2 minutes, 10 seconds, and counting. The target for the Apollo 11 astronauts, the moon at liftoff, will be at a distance of 218,096 miles away. We just passed the 2-minute mark in the countdown. T-minus 1 minute, 54 seconds, and counting. Our status board indicates that the oxidizer tanks from the second and third stages now have pressurized. We've continued to build up pressure in all 3 stages here at the last minute to prepare it for liftoff. T-minus 1 minute, 35 seconds on the Apollo mission, the flight to land of the first men on the moon. All indications coming in to the control center at this time indicate we are go. 1 minute, 25 seconds and counting. Our status board indicates the third stage completely pressurized. 80-second mark has now been passed. We'll go on full internal power at the 50-second mark in the countdown. Guidance system goes on internal at 17 seconds, leading up to the ignition sequence at 8.9 seconds. We're approaching the 60-second mark on the Apollo. T-minus 60 seconds and counting. We passed T-minus 60. 55 seconds and counting. Neil Armstrong just reported back it's been a real smooth countdown. We passed the 50-second mark. Power transfer is complete. We're on internal power with the launch vehicle at this time.
No motion.
40 seconds away
No motion.
from the Apollo 11 liftoff. All the second stage tanks now pressurized. 35 seconds and counting. We are still go with Apollo 11. 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 10, 9, 8. Ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. We have
Commit.
And we have liftoff.
Yaw program complete. Roll program start. Roll complete. Pitching program. One Bravo. Standing by for max Q. Max Q is the point of maximum dynamic pressure on the vehicle. Go at 1. That hissing noise.
Mode 1, Charlie. Mark, mode 1, Charlie.
That hissing noise you hear, that's the pressure building up. We've got maximum pressure. They called out that 1 Charlie early. I'm gonna have to go into the files and fix that. But doesn't matter because I know when it actually happens. Stand by for mode 1 Charlie.
Staging status booster. Go. Fired up.
Mode 1 Charlie.
Go. Set for staging cap now.
Okay, area of attack looks good. Standing by for inboard cutoff.
Inboard engines out.
Come inboard, got him. How you econ? Or go flight. GNC. Or go flight. Gotcha.
Standing by for launch tower jettison. Staging. And ignition. Clean the tower, yes. The tower is very clean. I thank you for your work. The Apollo program thanks you for making that tower look absolutely beautiful today. It's important that it looks beautiful. Skirt sep. Mode 2. Tower's gone. There she goes. Activating glycol evaporator.
Let me know when it converges, guys. Right. Looks good, flight converged.
Steering converged. I gotta say, the Saturn V without the S1C or with the S2, just this configuration, it looks really weird.
Hi, how you, booster? We're go flight. GNC. We're go flight. Surgeon. Go flight. We're good at 4 minutes, Captain.
Go at 4. So what do you guys think? Should we watch from the outside or go back to the inside with all the noise? Oh, hey, there's our target.
Guidance, flight, how you? We're in great shape, flight, go. Flight Fido, go. All trajectory sources agree, we're go. Roger. How you look, booster? Booster flight. Go flight. All look okay. That's a firm flight, looking good. Econ flight, how you? We're looking good, flight. Good at 5 minutes, Captain.
Go at 5.
Stand by for S4B to COI capability. Mark.
S4B to COI capability, roger. Trims in. Going to Omni Delta. Signal strength renewed. Omni Delta. Okay. We're cruising along here. Orbit so far is looking real good. Very loud in here. But the sound should be getting quieter. Stand by for S2 inboard engine cutout. 30 seconds. 20. 10 seconds. 3, 2, 1. Inboard cutout. Standing by for level sense arm of staging sequence. Level sense arm 8+1 7 staging 9+1 1 propellant utilization shift detected. Stand by for mode 4 capability. 6, 5, 4, 3, 2, 1. Mode 4 capability. Staging at 9+1 1. Staging. And ignition. Thrust is go. We do read. We are go for orbit at this time. Go for orbit. Predicted cutoff 11+4 5. Okay. We are approximately 30 seconds now from cutoff. Mark, 30 seconds. Predicted cutoff is 11+4 2 with booster safing at 11+4 5. Oh, I lied. Cutoff is a little earlier than expected. But the app system is fine-tuning the insertion. So, just as expected, we are still go for orbit. Uh, 104 by 101.7 orbit. Looks really good. And how are our parameters looking? Row 1 and row 2 should equal 0 and be the same. That is correct. Parameters are looking good. Post-insertion checks. Can take the seats off now, if not for a small moment before TLI. Okay, S4B looks great. It looks great. I'd say we'd have a nominal TLI in a few. SMRCS, propellant quantities, pressure, and tank temperature looks good. How's that helium tank temperature? Also looking good. Quads B and C and D are a little low, but those heaters will bring them right back up. Looking real good for there. Command module RCS is meeting pre-press conditions. That's fantastic. Caution and warning system checkout. Good, we got no burnt out light bulbs, and the warning logic is working fine. And we actually are going to do the main regulator checkout before the suit circuit bypass. And the reason is because it's suit circuit bypass. As soon as you pull it, it purges the suit circuit with oxygen to relieve the CO2 from the inside. So the next time you put it on, you don't choke and die. Kind of important. And this can disrupt the O2 flow readings for this test. So now we'll do the suit circuit return bypass, and we can see, as I said, it disrupts this gauge for this test. So secondary radiator leak check. So our leak check for the secondary radiator system is looking pretty good so far. Accumulator is going good. We are in a very, very stable orbit now. Tank is doing its propulsive venting at this time. And secondary accumulator quantity does hold, so we can say that the secondary coolant loop required for reentry is go at this time. Let's bring us forward to ECS post insertion configuration. So how is everyone doing today? I gotta say, I am having a mighty time flying. Bypass the glycol reservoir. We probably are not going to get to TLI today, but for sure tomorrow, pretty early. And I'll make sure that you are there. For sure. I will wait on stream for you to join. Tomorrow, probably around the same time. Okay, we do read primary glycol flow. Heater on. Potable heater on. Uplink telemetry command reset. And norm VHF simplex. Be off. Glycol in temp auto. Very good. Purge check now. O2 purge check. Looks great. Purge line heater off. Electrical power systems. That's the exact wrong one. There we go. Electrical power systems. Let's take a look. Pressures and quantities of the cryoreact reservoirs are great. Propellant pressures on the S4B are indeed in the green. We show a oxidizer pressure of around just above 400 psi, and the fuel pressure just above 200 psi. And all fuel cell flows for the power plant are in the green. And our DC power plant fuel cells are putting out good. Main buses show stable volts and amps. Battery bus shows batteries are indeed charged. Isolated battery C is charged, and the pyrobats are charged. All of that is go. And we have been charging the batteries for a very long time before the launch, so it is quite possible, if we come to test 4B, that, yep, the battery manifold does need to be vented of the flammable gas. So we will vent that manifold. And that indeed is looking good. Battery manifold is vented. AC power plants, let's take a look at that. AC power plant shows stable volts on all three phases. It's very good. Environmental control system checks. Surge tank pressure is good. Primary tank pressure is good. We are confirmed boiling on the evaporator boiler for the cooling system. And our pump discharge pressure is normal. Temps look great. Compressors look great. Accumulator quantity does look great. And we do not need to perform a wastewater dump. And our potable water looks good. Temperatures and pressures are great. And the CO2 mercury meter is good. SPS monitoring shows SPS temperature is good. Helium pressurizant is good. Nitrogen valve actuator tanks are good as well. And the injector valves are closed. Helium valves closed. Quantity looks great. Let's test the meter. And the meter is good. GDC and IMU show good alignment. Now I'll need to grab a calculator. 107.8 plus 102.4 divided by 2 is 105.1. Looks good. And we did set up our ordeal now. And a ECS redundant component check. Looks good. I just gotta wait 5 minutes, watch these temperatures and pressures stabilize, and it is all good there. And spin down. And now we just need to do a IMU alignment, which occurs shortly. The view is really good. Yep. Yes. Hot water produced by ourselves. Yeah, you're not wrong about that. That sounds gross, but just a little bit of fuel cell hot water, and then you add some chlorine to sterilize it, and then some sodium hydroxide to neutralize the water. Bam! Drinking water to neutralize the chlorine, that is. Sodium hydroxide is normally not drinkable. Don't drink it. It's just the chlorine neutralizes the sodium hydroxide, and the sodium hydroxide neutralizes the chlorine, right? The reason both of those are really dangerous to drink, it's not because of what they're made out of. I mean, after all, we get lots of chlorine from table salt. It's just the pH, the level of acidity, that makes it really dangerous, right? So sodium hydroxide is really acidic. You'll burn yourself, and bleach is really basic, so you'll burn yourself. A base burn hurts a lot worse than an acid burn, if you're wondering. Yeah, the reason a base burn hurts a lot worse is because, of course, humans themselves are acidic. So acids, unless they're really extreme, like sodium hydroxide, they don't really burn you too much. You know, like tomatoes, French fries, this sort of thing. The really acidic stuff, it doesn't burn. But bleach, that burns. So optics power on, 0 switch off. And let's get that dust cover jettison, shall we? There we go. There go the optics covers. Goodbye. We are about to pass right over Australia, so if anyone on the stream lives there, maybe you can look up and see the S4B, yeah? I do jest a little bit, obviously. It's not 1969. Coupling. There we go. Coupling direct versus coupling resolved. It'll get you every time. Okay, Antares, we got you. Just wait till you see the Earth or the Moon through these optics. It's like nothing you've ever seen before. Apollo 9 is by far my favorite mission in this entire game, and I don't play it because there's not really much of a tutorial you can make with it. The procedures are so inapplicable for the rest of the missions. It's you know, the first time I flew the LEM, it's just different, all right? It's just different. IMU alignment complete. And GDC is even better aligned than it was before, so good on that. In future streams, I will have my auto-clicking mouse, so we don't need to listen to this ridiculously annoying noise. Okay, good. That's just a test we do so that Houston knows how to calculate our burn angles based on a bias in the system. And now we get a good time of just, well, time skipping. Hello, Australia. Earth. Yeah, no, duh. Wow, I did not know that we were orbiting Earth at all. Tremendous Earth. Yeah, the rendering is great. The virtual cockpit's not too great. You know, Reentry's virtual cockpit is a little better, but this definitely has the most realistic sim. Oh, far more realistic than Reentry spaceflight simulator. And I gotta say, the Earth model is just way better. When we were doing those Gemini flights with all the flickering and all that, ooh, it was driving me nuts. Goodbye, Australia. Point lookout. And hello, Oceania. Not like Australia isn't in Oceania, but for whatever reason, Americans classify Australia as its own continent and Oceania as its own continent, even though Australia is a country within the continent of Oceania. Americans are weird. All right, now we're just over the ocean, so we'll cruise along a little bit faster, but not too fast. Not so fast that the apps on the S4B turns off, which is a real danger. And here comes the sun. Do 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 do. I hope I don't get copyrighted for that literal 2 seconds of me making a joke. If I do, then YouTube is gone absolutely banana pants these days. And we are about to cover or come right over the top of Mexico. And I did just get confirmation by telemetry that our optics covers did just burn up in the atmosphere just now. Very good for them. Good morning. Good morning, Mexico. And here we are. This is an abort pad. And we do have a state vector update. So we will uplink that the moment the computer stops calculating stuff. There we go. Uplink. Uplink complete. State vector update and verb 66. Good. Yes. The docking probe is extended prior to TLI, and it makes the most amazing noise ever. And we arm the retract system. Yes, Apollo 8. We can do the Apollo 8 mission as well. So this simulator supports Apollo 7, Apollo 8, Apollo 9, Apollo 10, Apollo 11, Apollo 12, all with the sort of MCC that gives you these pads. You can do Apollo 13, 14, 15, 16, and 17 if you know how to calculate your own burns. You can also do the historic never flown Apollo 2, which would have flown if Apollo 1 fire never happened, where the LEM and the CSM are actually launched on different vehicles, and they do a CSM rendezvous and docking, and then they undock the LEM, and then they do a LEM active rendezvous and docking. It's a very fun mission that I'm in the process of doing. And they also have the ability for you to do your own. Land anywhere you want on the moon, provided you have the fuel to get there, and the ability to map the details of the terrain in 5 vectors or less. So it's got it all, and it will very shortly have Skylab as well. Here is our TLI pad. We may have the time to actually pull this one off. We won't be able to do the undocking or anything, probably, but we may have the time to do this. All right, SMRCS hot fire test. Looks good. And now the coast. The glorious, glorious coast. This is our second orbit, so we will be doing TLI very shortly. Here we are. TLI checklist. EMS entry monitoring system checkout is looking good, so we will be able to use it to monitor our burn. And we are looking at a delta V of 10,417.7. And that is well good enough for TLI. Yeah, we're fine in that regard. Okay. First installment of the Apollo Lunar series of tutorials is TLI. So we've walked up through all of the tests and all the setup and the switch positions. And so all of this should be familiar with you using the EMS, all of that jazz. Now it's just sort of the rough sequencing of a TLI. But if you haven't watched the regular tutorial series, then I highly recommend you do so before continuing the this video here. So we will be approaching our time base 6 initialization. So we'll go ahead and time skip forward. We'll time skip gently because we don't want the apps to give out by having it go too fast. And it definitely can. If you're not careful with the time skipping, the apps will give out on you. Okay, so now we stand by to start the clock. When the engine light or the S2 SEP light comes on, yep, stand by, have your mouse over the event time start, and as soon as that light turns off, hit the switch, and you'll be on time base 6. Time base 6, S2 SEP light off, counting up. Make sure we're SCS, and all telemetry uplinks will be blocked at this time. And yes, I do agree Apollo 12 is better than Apollo 11. I think my favorite, though, has got to be Apollo 17. And yep, at this time, set your altitude dial on the ordeal to 300. Switch lunar. Orbit rate, inertial, and now hold fast. When the event timer shows 57 minutes, we are going to slew to 15 degrees of pitch. So bring it forward very carefully. This ordeal is used to time the ignition of the S4B engine. So here, slew to 15 degrees. And now we start verb 37, enter 47. This is the thrust monitoring program. So program 47 is coming in now, and we will see our pip accounts. There we go. Now bring it along to the event timer says 58 minutes. Noun 62, enter. And for logic reasons, TVC 1 needs to be on. Bit rate high. Uplink telemetry command reset, then norm. At 58:34. EMS mode normal. S2 SEP light on. And ullage will begin at 58:38. Here we have ullage. At 59 minutes, we just slew the pitch angle to 7 degrees. At 59:42, S2 SEP light will be off. S2 SEP light off. Fuel lead. Standing by for ignition. Let's get the seats. Always forget that. 55, ullage complete. Ordeal mode slow. And there's ignition. they'll be monitoring the EMS here and your data outputs here. So, of course, I'll be with you when the burn is complete. And there is the cutoff. Key release. S4B initiates its attitude hold now until 20 seconds. And then we begin the heads down maneuver. And there she goes. And you can stow your ordeal now. Terminate program 47. And that does it for the TLI. Thanks for watching. Alrighty, so I think I think that we may stop here. I think, yeah. What do you think, Mr. Istvan? Did you want to stop here? This is before docking. I think maybe we'll stop it here. So yeah, thanks for stopping by, and next time we will be doing the docking. Much appreciated.